Okay, good morning, dear students. How are you? I hope all of you are fine. Yes. Okay, here, what is this? Yes, you're all familiar with this. This is nothing but chessboard. Okay, why I placed this as chessboard here? Okay, I have one story about this chessboard. I have one story. Let's share with you. The king of Persia was so happy with the game of the chess that he offered the inventor any rewards he wanted. The inventor asked for a grain of wheat to be placed on the first square and on the chessboard, two grains on the second square, and four grains on the third square, and so on. Every time doubling the number of the grains. Okay, the king of that Persian is very happy with this game. So for that, the king offered the inventor of the chess game whatever the reward he want. But that modest was that the inventor of the chess game, he asked it very what is that? What he asked it just a wheat grains. That is, on the first chessboard, you need to place one wheat grain, and the second square of the chessboard, you need to place two wheat grains. And next time you should double. After what is the double of two? Double of two is four. So you should place here four wheat grains. So then next year you have to place eight. So here you have to place 16. So here I have to place 32. So here I have to place 64. Like that, keep on going. So until where to reach the last chessboard, means last square in the chessboard. So this is seems to be very modest to the king. So why? Because king offered the very good rewards to this inventor of chessboard, but he asked only the wheat grains, that is only to place on the that is countable wheat grains he asking. So it is seems to be modest, but the demand of the inventor seems to be modest, but it is proved that it's a very big problem for the king to fulfill this his demand. It is very what is that, very big problem we face it. So why it is to understand this, why this problem, and also how to solve this problems, you should be familiar with the sequence. Okay, you should be familiar with the sequence. So what is sequence? So just look into these numbers 1, 5, 9, 13, 17. So and what is the next set of numbers? 1000, 100, 10, 1, 1 by 10, etc. And next 1, 4, 9, 16, 25, etc. And 0, 7, 26, 63, 124, all these numbers. So in all these numbers, do you see any common pattern? Do you observe anything special in these numbers? I hope you not observed, but here some special is there. What is the special? We'll see now. Okay, just look into the first pattern. So here 1, 5, 9, 13, 17 is there. So here what happened? The first number 1 and second number 5. So 5 you can write as a 1 plus 4, and third number 9. So you can write it as 5 plus 4, and the fourth number 13 we can write here 9 plus 4, and fifth number, that is 17, you can write here 13 plus 4. So what is the rule they are following here? They're following the rule, that is they're adding 4 every time to all the numbers. Okay, so now next, a thousand, 100, 10, 1, 1 by 10 is there. What is the rule they're following here? The rule is nothing but multiplying by 1 by 10. So if you multiply by 1 by 10 or divide by 10, so what you'll get? What you'll get? These numbers. Okay, so next year 1 4 sorry 1 4 9 16 25 is there. So what they did here, it is nothing but square of natural numbers. When you square the natural numbers, so 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25. So this is nothing but square of natural numbers. And next year 0 7 26 30 63 20 124 is there. So what is this? This is nothing but cube of natural number minus 1. Cube of natural number minus 1. So what did cube? So 1 cube is 1. 1 cube is equal to 1. So 1 minus 1 is equal to 0. And next one is 2 cube. 2 cube is 8. So 8 minus 1 is equal to 7. And 3 cube. 3 cube is equals to 27. So 27 minus 1 is equal to 26. So like this is keep on going, like this, it keep on going. So this an orderly arrangement of a number according to certain rules, according to certain rule, is called as sequence. So what is sequence? An orderly arrangement of a number according to certain rule is called a sequence. Sequence is an orderly arrangement of a number according to certain rules is known as sequence, is called as sequence. Okay. Okay, and this type of sequence is not there in a syllabus, but as a competitive examination point of view, if you want to take the KS, KPSC exams like FDA, SDA, or any other competitive exams like IPS, IAS, on those papers, this type of questions will be appear for at least 2 to 3 marks in the competitive exams. Okay, and this concept is not there in your syllabus, but it is there in the late, I mean the last year textbook, it was there, but now it is not there in your syllabus. Okay, so now let's see the some more extended quality of this sequence, some more extended thing of this sequence. Okay, what is that? We'll see now. Okay, look into this pattern: 5, 8, 11, 14, 3, 13, 23, 33, 1, minus 1, minus 3, minus 5, 1, 1.5, 2, 2.5. So what they did here, so we can call this as terms. This 5 is first term, 8 is second term, 11 is third term, 14 is fourth term, like that. And also the terms we can write as A1, A2, A3, like that. So here A1 is equals to 5, and A2 which is equals to 8, A3 is equals to 11, A4 is equals to 14. So like this it's keep on going. So now what they did here, they did the A2 minus A1, A3 minus A2, A4 minus A3. Okay, so what they got, so they got, what is that, all the numbers are 3. And here again, here 3, 13, 23, 33, again what they did, so they did this subtraction of the two numbers, that is a2 minus a1, a3 minus a2, a4 minus a3. So what they got, they got 10, so all the numbers 10. So here also they did, so they get all the numbers negative 2, and also they did that last one, so they got all the numbers 0.5. So now tell me what is the difference, what you inferred from this, what you observed from this. Okay, the above sequence demonstrate two common factors. Okay, common facts. So what is that? Each sequence start with a number chosen randomly. So if they taken the number here randomly, they not take any particular numbers here, they taken the random numbers. Okay, second uh, fact in this is every successive number is the in the list is formed by adding some fixed number to the preceding number. What do you mean by this? Every successive number, what do you mean by the word successive number? Successive number is nothing but the next number. See here 5 is the first number, the successive of the 5 is 8, and the successive of 8 is 11, the successive of 11 is, just tell me what, it is nothing but 14. Yes, so here also 3 is the number, in that the 3, the successive number of 3 is 13. What is the successive number of 23? 33. Here what is the successive number of minus 3 in this? Are you able to see my arrow mark? What is the successive number of minus 3? So this minus 3 is nothing but minus 5. And here also 1 is the number, the successive number of this 1 is 1.5, and 1.5 successive number is 2, 2 successive number is 2.5. Okay, so therefore every successive number in the list is formed by, it is formed, how it is formed? It is formed by adding some fixed number, adding some fixed number to the preceding number. Preceding number in the sense back number, what is that? So this is the preceding number. So successive number in the sense front number, preceding number in the sense the 11, 8 is the preceding for the 11, 13 is the preceding for 23, like that. Every successive number is a in the list is formed by adding a some fixed number to the preceding preceding number. Okay, then what is this called? This is this is nothing but we can call this as an AP. What is AP? That is arithmetic progression. In today's class, let us study about this concept, arithmetic progression. In today's class, let us study about arithmetic progressions. And as an examination point of view, this chapter is important for you, around 9 to 10 marks. In the final examination, from this entire chapter, you may expect around 9 marks to 10 marks. As examination point of view, it is very important for 9 to 10 marks. Okay, so now let us see some more. What is arithmetic progression, what is AP, and all those things. So arithmetic progression, this is a definition of arithmetic progression. Arithmetic progression is a sequence, yes, is a sequence in which each term is obtained by adding a fixed number to the preceding term except the first term. So in arithmetic progression is a sequence in which each term is obtained by adding a fixed number to the preceding term except the first term. Okay, so now in an AP, the difference between any two terms. Okay, we'll do, before going for that difference, we'll give an example. So what is example of an AP? So you can take this example only, that is, what is that, 5, 8, 11, 14. So here 5, 8, 11, 14. So this is nothing but the terms. Okay, they are what they telling here, terms, right? They're talking about here the terms. They're talking that here is terms, that these terms are nothing but this terms. So this is terms. So you can call this as A1, you can call this as A2, this is A3, and this is A4. How many terms were there? So many are there. So if you want, you can, we'll discuss about it later. Okay, these are nothing but terms. Okay, so now, so in an AP, the difference between any terms that is preceding term is a constant. This is called as a common difference. So here, just now we seen here, what is that, A2 minus A1, A3 minus A2, A4 minus A3. What is all these things? So it is nothing but the difference. They're doing subtraction. Subtraction, the other word of subtract, another name of the subtraction is nothing but difference. So we can call this as common difference, and also it is represented by a letter, small letter d, small alphabet d. Okay, so here that in an AP, the difference between any terms and its preceding terms is constant. In an AP, the difference between any terms and its preceding term is a constant. This is called a common difference. This is known as the common difference. So, and you can write here common difference d is equals to, that is, A2 minus A1, or also you can write here d is equals to A3 minus A2, or d is equals to A4 minus A3, like that. You can keep on giving the numbers if I keep on giving this one. Okay, so I hope you understood this. Okay, in an AP, the common difference can be either be positive, the common difference what we obtained here, see here, we obtained here, it may be here, it is positive, it may be a positive, or it may be a negative, or it may be a zero also. So it may be positive, negative, or it may be zero. Okay, so even the fractions, decimal numbers also there, so it may be decimal numbers also. So in an AP, the common difference can be either be positive, or be negative, or be zero. I hope all of you understood. Okay, so next, so look here, this is the types of AP, that is finite AP. Finite, here it is finite AP. What is finite AP? A AP contains finite number of terms. AP contains finite number of terms. Such an AP is called as finite AP. So an AP contains finite number of terms. Such an AP is known as finite AP. For example, so you can write this one only. What is it? 5 comma, example 5 comma 8 comma 11 comma uh, something you wrote of 14. Okay, This is the example of the finite AP. Okay, so now, and infinite AP. What is infinite AP? An AP contains finite number of terms. Such an AP contain infinite number of terms. Such an AP is called as infinite AP. The example 5, 8, 11, 14. So both the examples are same here. Is both are same? Yes, but the small change is there. So here it will end at some point. So here only 4 terms we have, but here I put it some dots. This dot indicates that it is infinite. So many terms were there in this AP. It concludes that so many terms were there in this AP. Okay, I hope all of you understood. So now just what we studied now. So you say that arithmetic progression is a sequence in which each term is obtained by adding a fixed number to the preceding term, and CD is nothing a common difference. You can abbreviate it as CD or denoted by small letter d. Okay, so the next is finite AP and infinite AP. Okay, when the AP contain finite number of terms is known as finite AP, and AP contain infinite number of terms, it is called an infinite AP. Okay, I hope all of you understood this. Okay, so now next, now we do one thing. Now list, I'll assign you some homework. So list the few examples of arithmetic progression, that is AP, and also find the difference, uh, difference for that arithmetic progression by yourself. No, you mean what I mean to say is, so you only write the examples. So write list the examples of AP. Okay, list the examples of AP, your own example. List example of AP and find find common difference for that. Find common difference for that. Okay, so this you should be doing the homework. And also list finite and infinite AP's example. So list, this is find the example. Okay, list at least 10, list 10 examples of AP and find the common difference for that. And this is the first one. And second one, list again 10 finite and infinite APs.